first order reaction has a specific reaction rate of 10 to the power minus 2 per second. How much time will it take for 20 gram of the reactant to reduce to 5 gram? So we know the formula, rate constant is equal to 2.303 and divided by time taken and log of initial concentration and the concentration decomposed. So in this case, specific rate constant given 10 per minus 2, right? Okay. And time is given here. So this is time we have to find 2.303 and the time we need to find out and log, and A is given 20 gram and divided by this is the 5 gram. We will solve it. On solving we'll get time we can take this side 2.303 and divide by 10 per minus 2, and this is 4. So 4 means 2 log 2. So 2 log 2 means 2.333 into log 2. This will be 0.0693 divided by 10 to the power minus 2. And if you solve it, on solving you will get to 138.6 seconds. So out of 4 choice, we see carefully. So answer of 4 is correct answer. A gas is allowed to expand in a well-insulated container, against a constant external pressure of 2.5 atmosphere from the initial volume 2.5 liter to a final volume 4.5 liter. The change in internal energy of the gas in joules will be what? So we can apply the first law of thermodynamics, that is delta U is equal to Q plus W. And you see carefully, this is the insulated container, so that definitely Q is equal to 0, and this is an adiabatic process. Why? Because it is a container insulated. In insulated container, heat cannot go inside. So we'll get the equation delta U is equal to delta Q, and Q is 0, delta U equal to W, and W is nothing but the P delta V, and P is given, if you see carefully, P is given minus 2.5, and V is nothing but the V2 minus V1. So V2 final pressure, initial pressure, final pressure. So 4.5 minus 2.5 liter. So on solving you will get here, so this is 2.5 into 2 liter atmosphere. If you solve it, it becomes your minus 5 liter atmosphere, and we can convert minus 5 liter atmosphere is nothing but the 101.3 joule. So this you will get minus 506.5 joule, or total energy will be your minus 505 joule. So this is our answer. So let us say check it. So if you see carefully, so which option correct? So in this case, if you see carefully, it is coming 505. So one answer is correct. Which one is the correct order of acidity? So we'll find out which contain our acidic hydrogen. So here we have 2 acidic hydrogen in acetylene, no acidic hydrogen. Here we have 1 acidic hydrogen in propine. This is alkane. So order should be this should be first, this would be second. So we'll search out such options. This is wrong option. If you see carefully, this is again wrong options, and this is the correct options, because there are 2 acidic hydrogen in 4 case. So acidic and 2 acidic, 1 here and 1 here, and in this case 1 acidic hydrogen, then this alkene, and this is your alkyne. Even you can see this is the alkyne, this is the acidic hydrogen, this is the sp hybridization, is more electronegative. This is having the again sp hybridization, because 1 acidic hydrogen, here 1 acidic hydrogen, here 2 acidic hydrogen, and this is your sp2 and this is your sp3. So based on electronegativity also we can see that this is more acidic, this is less acidic, and this is the again less acidic, this is the least acidic. So answer 4 is correct answer. Which of the following is a sink for carbon monoxide? So sink is a big source, the sink which will absorb the carbon monoxide in large amount. So it is the, if you see carefully, oceans. No, ocean is not there. Ocean can absorb the carbon monoxide. Plants, hemoglobin. Answer 4 is correct. So this is the only correct answers. Microorganism present in the soil is only can absorb carbon monoxide in large quantities. So this is our correct answer. If molality of the dilute solution is double, the value of molar depression constant will be what? So we know this is the question of liquid solutions. So we know the formula For freezing, we say delta tangent freezing point of depression will be equal to I into Ventov factor multiplied by Kf into molality. Now this is doubled, so this is that doubled, okay, and dilute solution and the Kf. So Kf is a constant value. So this will be doubled, means either it is affecting this one, or this will be something affecting this one, or this will be affecting this one. But they're asking what is the value of Kf. So Kf, if it is double, triple, whatever the value of the molality, so it will not change the Kf of the solution. So what is the answer? So answer is Kf will be triple, wrong. Kf will be unchanged. So anyhow, the second answer is correct. It will be unchanged. Double half is wrong answer. With respect to the conformers of ethane, which are the following statements true? So bond angle, bond length will change. Bond angle, bond. Let's check first that this ethane molecules. If you draw the ethane molecules, it is like that. So it will be your C and C. If you draw the conformers, so if you take CS2, this is your hydrogen. This is the hydrogen, and again this is the hydrogen. This is hydrogen, and this is the Sawhorse projection. If you see carefully, this angle is 60 degree, and bond length is again single bond is there, so it will be your something 154 angstrom. So all will be CC bonds, and CH bond will be also fixed. So bond length is also fixed, bond angle will be also fixed. If you rotate it, this is sigma bond. If you rotate it to all bonds, it will be 6. Means you can see the bond angle and bond length. Okay, in this case both will be same, whatever you will change the position. So if you see from this side, if you see from this side, anyway it will be same. So let us see the option. Options is bond angle and bond length will change as a wrong. Bond angle and bond length will remain same. So this is only seeing correct answer. But we say the next one, bond angle remains same, but bond length change, wrong. Bond angle change, but bond length remain same. So on anyhow, we are getting the second answer correct. This one. So this is the correct answer. Pick out the correct statement with respect to MnCN6 whole 3. So the other statement. So first we have to solve MnCN3. So MnCN3. So this will be your Mn, and whole is Cn3, and this is the thrice 3 negative. So what is the charge of manganese? So whole is 3. So what is charge of manganese? So manganese will be your this is x plus 3 into minus 1 is equal to minus 3. So this is the not, it is 6 minus 6, so it will be 6, so it will equal x equal to, you can see, so it is a minus 3 plus 6, it will be your plus 3. So charge is your, for Mn charge is your plus 3. So plus 3 means, if you see the configuration, so configuration will be argon 20, after 20 there is 3 electrons, 4 is removed, so this will be 3d4. So this is your configuration, 3d4 state. So we can draw the diagram. The 3d4 space, so this will give the idea of T, 2T and 4, and this is easy 0. Why is it 0? Because if you see Cn is your strong ligand, it is your strong ligand, so definitely this is strong ligand, and that's why this electrons will be paired up, so we'll get the configurations like this one. So this is the 1, 2, 3, 4, 5, and we have next is this electron, and next is our, this is the 4p. So in case of this is 4p, so 4 electron, they have 4 electrons is there, so we can write here 1, 2, 3 and 4, sorry here 4. So this 2 is blank, this is blank, this is your 3d, this is your 4s, and this is your 4p. So we have hybridations here D2sp3. This is hybridation. So this hybridation will says that structure will be octahedral. So this is octahedral hybridation. So yeah, structure hybridation octahedral, and structure will be D2sp3. Let us check it out. So D2sp3. So only first is coming correct. Octahedral D2sp3. This is wrong. This is wrong. This is wrong. So this is correct answer. Which of the following pairs of compound is isoelectronic and isostructural? We'll check it here. IBr2. So IBr2 will be written as a like this one. This is the I, and this is the lone pair, and this is the lone pair, and this is the lone pair, and Br is up and Br is down. And xenon fluoride, this is the xenon, this is the fluorine, this is the fluorine, and this is one fluorine, and this is structure, this is the structure. So by seeing the structure, this can be isoelectronic as well as isostructural. Both here, that's 3 lone pairs and 2 bond pairs, 3 lone pairs and 2 bond pairs. In case of IF3, so IF3, if you draw a structure, this is the I, this is the fluorine. Here fluorine equatorial plane, this is fluorine, and this is 1 electrons, this is 1 electron. And xenon fluoride we have already drawn. BeCl through, so BeCl is like this one. So this structure will be linear. Okay, this is the planar structure is there. And next is Ti2. So Ti2, if you draw it, this is T, this is the I, and this is your I, and this is your lone pair, and this is the lone pair. So this is the angle just like a water molecule. This is the bent structures. So if you see the structure wise, which is isoelectronic, so this only is isoelectronic and isostructure. So these two are isoelectronic and structure. So this answer is our correct answer. Which one of the following statement is not correct? So we have to find out incorrect statement in this. Enzymes catalyze mainly biochemical reaction. This is the correct statement. Yes, enzymes are acting as a catalyst. Coenzymes increase the catalytic activity of the enzymes. Correct. So enzymes are again attached by some compound. It's called coenzymes. It will increase the catalytic activities. Catalyst does not initiate any reactions. No, it will initiate these reactions. Okay, because what is the role of catalyst? Catalyst is actually, it is decrease the activation energy during the forward and backward reactions by same amount. Okay, see, and it will speed up forward and backward reaction by the same rates. So this is the role of the activation energy which is done by the catalysts. And equilibrium constant, the equilibrium constant is not affected by the catalyst at any given temperature. So here the value of equilibrium constant is changed. So this is the only wrong statement. So they are asking which is the wrong statement. So a catalyst cannot change the equilibrium constant. This is only the wrong statement because they are writing the equilibrium constant is changed. This is only wrong statement. Concentration of silver ions in a saturated solution of Ag2C2O4 is 2.2 into 10 to the minus 4 mole per liter. So this is the concentration of silver ion on this one solution. So how we write Ag2C2O4, and it will split into Ag plus and C2O4 2 minus. So here is 2 concentration. So solubility of silver will be 2S, and this is the S. So KSP is nothing but the product of these 2 concentrations. So this is the concentration of Ag plus whole square because the power is 2, and then multiplied by C2O4 2 minus. And the given question says that what is the concentration of Ag? Concentration of Ag is already given, that is 2.2 into 10 to the power minus 4. Then what is the concentration of oxalate? Oxalate is half of Ag concentration. So concentration of oxalate will be half of this one. So half means what? 2.2 into 10 to the power minus 4 by 2. So it is nothing but the 1.1. 1.1 into 10 to the power minus 4 concentration. That is the molarity. So if you use this value, see here is 2.2 into 10 to the power minus 4, and this is the whole square, and concentration of oxalate is 1.1 into 10 to the power minus 4. This is the concentration. So if you multiply it, square means you will get, on solving, answer will be 5.324 into 10 to the power minus, it is 8.412. So this is the whole concentration. So let us check answer. Answer will be in this case, if you see 5.324. So answer is again, this is the correct answer. The reason for the greater range of oxidation state in the actinide is attributed to, so we have 5F, 4D, 7S levels having the comparable energy. So definitely in actinides has the greater number of oxidation states. So these orbitals are very close to each other because this is the only electronic configuration for actinoids. So due to this may be correct answers. 4F, 4D levels being close to energies. This is applicable for the lanthanide contraction, this one, second one. And the third is radioactive nature of actinoids. No, this is wrong answer. Actinoid contraction. No, this is again wrong answer. So answer is only this is correct. In the electrochemical cell, this is the concentration. Zinc and copper is given. This is the metal ion solution. Electrode, the EMF of the Daniell cell is even. So for this even, when the concentration of zinc sulfate initially 1 molarity change to 1 molarity, and if you are changing the copper sulfate it's 0.01 molarity, then EMF will be changed to E2. So when you are changing concentration 0.01 to 1, and for copper 1 to 0.01, so both are almost reverse. So previously it was E1, next is E2. So what is the following relationship? So first you find out So E1 will be how much? So E1, by using a Nernst equation, E1, so E naught of the cell is constant, and this is nothing but it is a 0.059 divided by n. Okay, and this will be multiplied by log. So E1 will be log initial concentration of anodic is for zinc is 0.01 and divide by 1. This is the E1 concentration. Now second, E2 will be how much? So E2, E naught of cell will be same, but here 0.059 divided by 2, this will be same, and log, and the second is it is changing to 1 divided by 0.01. So we can see clearly, so this value will be greater because this is a lower value, so definitely the E2 will be greater, and here this is the smaller value, so this will be smaller. So we can say very easily, so E1 cell will be definitely greater than our E2. So this is our correct answer. So let us check which of the following answers correct. So after seeing this is, so which is correct answer? So E1 is greater, so this is our correct answer. Identify A and predict the type of reactions. So this is the OCS3 and Br at a meta position, and we are using the sodium amide. So we have a reaction, sign substitution and eliminations out of this. So before going this one, we have to first check the reaction. So this is our reaction. So reaction is OCS3 and Br. This is amide. Amide is a strong base, so it will abstract hydrogen from the ortho position. It becomes a negative charge. And after the electron present here, so definitely Br will be eliminated, and this will become positive, so it will form a benzene. So benzene is a compound. Now benzene is attacked by again amide, so in two ways, one this side and this side. So this is one pathway A and pathway B. So on pathway A and pathway B, if you see carefully, so when amide is here, so amide is on presence of amide, so this is the ortho position of OCS3. Also this is an ortho group is, again it is the electron very close to this electron your withdrawing groups. So this position is very difficult, so it is very unstable, and while this is the again far away from here, so this is most stable groups. Okay, so incoming, this is nucleophile, this amide will attack on the where it will attack the meta position. Okay, so definitely this is not the sign substitution. So sign means if it is attacking over, this is sign substitution, so this is unstable, and this is the meta position, so this is not a sign substitution, this is only substitution reaction. So this is less stable, this is the most stable. So we have to find this answer only correct. So let us see which is the options. So in the question, so this is our result. Okay, and substitution reaction. So definitely the sign substitution is wrong, because here it won't form. This is not possible, and this is not possible. This is not elimination addition reaction. This will be substitution reaction. These two possibility 1, 2, and 4 is a wrong answer. So only this is correct answer. Which of the following is wrong statement? Half-filled, full-filled orbitals have the greater stability due to greater exchange energy and greater symmetry and more balanced arrangement. Okay, so wrong statement they are asking. So this is the correct statement. Definitely due to exchange of energy, this is greater inner stabilities. Second, the energy of 2s orbital less than that of energy of 2p orbital in case of hydrogen-like atoms. Hydrogen-like atoms means those atoms having single electron. So monoelectron atoms, so in this case 2s cannot be less than 2p energy. This will be 2s will be equal to 2p energy. Okay, so this statement is only appearing wrong statement. Let us check third and fourth. The de Broglie equivalence is given by lambda equal to h by mb. It's correct. And the uncertainty principle is delta E into delta is h by 4 pi, which is greater than equal to this energy. This is also correct statement. So 1, 3, and 4 correct. This is only a wrong statement. Our answer is second. The correct order of the stoichiometry of the AgCl formed when AgNO3 is in excess is treated with these complexes. With the complexes, and you will get this respectively. So if you take a COCl3 and dot 6 molecules of ammonia and reacting with the AgNO3 is nitrate, silver nitrate. So what happens? This is the silver nitrate, and you will get product. So what you will get products? This will be your CONH3, right? Whole is 6, and there will be your 3Cl. Cl will be out, Cl3 will be out, and you will get the AgCl. So this is our product, 3Ag AgCl. So like this. The correct order of stoichiometry of AgCl formed when silver nitrate is in excess treated with the complex COCl3, 6 is given here. COCl3 with 6 ammonia, 5 ammonium and 4 NH3. So this is the equation COCl3 and dot 6 NH3, and when you are reacting with the silver nitrate, and this is in excess quantity. So what is the product? So there will be this cobalt is a +3 state, so silver will completely react with the AgCl. So you will get here AgCl whole compound 3 AgCl, and you will get the complex CONH3. If it is whole 6, then this will be your 3, you can say 3 positive. And similarly, if you use COCl3 dot, next is 5 ammonia and with same, so you will get here 2 AgCl because 1 ammonia is reduced, and you will get here cobalt NH3 whole 5, 1 Cl is inside. So this is again here 3 positive, right? So next is COCl3, and again we have 4 NH3, and again same compounds. You will get here AgCl, and again inside this is the cobalt CO NH3 whole, this is a 4th, there are 2 Cl2 inside. So this will be how much? 2 Cl. So this will be again this will be your charge will be how much? So this will be your +1 charge, so you will get the 1 AgCl. So in this case +1 charge, this will be +2 charge, sorry, just to make a correction. So we have stoichiometry 3:2:1. So this is the silver chloride. So let us check answer. Which is the correct answer? So in this answer we can see this is the 3 AgCl, 2 AgCl, 1 AgCl. This is only correct answer. So remaining you see carefully is the wrong answer. All these are wrong answer. Name the gas that can readily decolorize the acidified KMnO4 solution. So this is the basic fact in this case which can decolorize. So answer is CO2 not possible, P2O5 not possible, N2 not possible. Only sulfur dioxide is only able to decolorize the potassium permanganate solution, and it will convert into your sulfate. So this is your answer 4 is correct. So this is our +4 state, and this is the +4. +4 can be again converted into your sulfate compounds possible. So +6 is possible. Remaining not possible. This +5 state, this is not possible, not possible, is also not possible. The correct statement regarding the electrophile. Electrophiles are generally a neutral species. Wrong answer. This is itself wrong. So generally not a neutral species. It can be positive, it can be negative. So this is not correct answer. Electron can be neutral or positively charged species. So this is correct. It can be form a bond by accepting a pair of electrons from a nucleophile. Yes, it can be positive charged species. So this can be your correct answer. Electron is a negatively charged species. No electron file cannot be negative. So it can. This is a absolutely wrong answer. Electrophile is negatively charged species and can form a bond by accepting a pair of electrons from the another. So electrophile. So this again your wrong answer. So electrophile is neutral or positive charge space. This is only correct answer. The species having the bond angle 120 degrees centigrade, 120 degrees. So what is the if you see the NCl3 is N, this is Cl, and this is a Cl and Cl, one lone pair is here. So 120 is not possible. In BCl3, so BCl3, Cl and Cl, so 120 is possible. This is the correct answer. And if you take PH3 is just like this one, NCl3, hydrogen, and one lone pair there. So 120 is again not possible. And if you take a ClF3, so ClF3 is like this one, Cl, 1 fluorine, and here is 1 fluorine, and here is 1 fluorine. This is your lone pair there. So 4 plus 7 lone pair there. So angle is having your how much 120 is possible. So this is the possibility of ClF3, but again if you see carefully, this can be possible. So this is again a wrong statement because this lone pair will along the equator. So we can write here Cl this side and 1 fluorine here, and 2 lone pair this side, and 1 fluorine here and 1 fluorine here. So this is almost a T-shaped structure. Okay, this is also wrong. So only answer this is correct. Which of the following statements not correct? Blood proteins, thrombin, fibrinogens are involved in blood clotting. So this is again correct answer. So they are involved in blood proteins, correct answer. Denaturation makes the protein more active. So this is only not the correct answer, because if you make the protein denatured, so what will happen? The globule proteins, here we have globule proteins, they are unfold, and helix, they are uncoiled. So here proteins will lose its biological activities. So it's not making more active, it will making inactive, because biological activity of the proteins is destroyed by uncoiling and unfolding by the globule proteins. So this is the only we can say the incorrect answer. Insulin maintains sugar level in the blood of a human body. Oh, this is happening correct. Oval albumin. Oval albumin is the simple food richer in egg white. Yes, this is appearing as a correct answer. Okay, so only this is the incorrect statement. Consider the reactions. So let us see. This is C2H6O. So C2H6O is the compound. We can say this is ethanol. So we can write here CH3CH2OH. This is ethanol. Ethanol is our X compound, and in presence of copper, so it will convert into copper 573 Kelvin. So this is the reaction. It will convert into your aldehyde CHO, and aldehyde in presence of your this tolerance reagents. Tolerance reagent will give silver observed. So CH3 further oxidized will oxidize to give you acetic acid. Right. So on heating here, and next is our this A compound. Okay, it is if you are reacting with the this is your NH2 NHCO NH2, so it will come onto Z compound, so it will undergo dehydration reaction. So like now this it becomes your CH3, and this is the CH and double bond N. So hydrogen plus oxygen, water molecules eliminated. So NH, this will convert into your semicarbazide. This is the semicarbazide. So semicarbazide is our this compound, and again this will undergo, this is the aldol condensation. You can see OH and heating, so you will get compound here CH3, and this is the CHOH, and next this will be your CH2CHO, and again further heating you will get here CH3 CH double bond CH and CHO. This is your butane but2-enol. So this is the aldol condensation reaction. So after this you can see this is the product Y. So which of the following is correct? So A is your, we can say A is ethanol, X ethanol. So X is our ethanol. We can say which A is our ethanol, X is ethanol, correct, and Y is butane 2-enol, that is also correct, and Z is semi-carbazone. So answer our A ethanol, this is ethanol, butanol, semi-carbazone. So this is our correct answer. Mechanism of the hypothetical reaction X2Y2 is given here. X2 is this one, X plus Y2 is XY plus Y and X plus Y. So we have to assume here first what is the rate of reaction of this equation. This is the rate is equal to K into X2 into Y2. Okay, and slow is the RDS reaction, so this will tell the rate. So rate is actually overall rate of this will be K into X and Y2, but here X is the intermediate because in the reactant X is there. So only first reaction, if you assume as a this one reversible reaction, then you can solve this equation. So assume this is a reversible reaction. So reversible reaction means K equivalent will be equal to this is X whole square divided by what is this is the X2. So X will be equal to how much? So this is implies that X will be equal to this will be square root of K equivalent into K whole square. So we can substitute this value over here. So rate will be equal to K into, now this is nothing but the K equivalent, the root K equivalent, and this is the X will be your X2 by 1 by 2, and this will be your Y by 2. Now they are asking overall order of the reaction. Overall order is overall order will be equal to order will be half plus 1. So this will be your 3 by 2. So this would be answer. So which answer we have to check it out. So answer is given 3 by 2 is your 1.5. So 1.5 is coming. So answer 2 is correct answer. Which of the following reaction is appropriate for the converting acetamide to methanamide? So let us see the reaction. This is the acetamide CH3CONH2, and if you use here Br2 plus sodium hydroxide, so this is the reagent and it will convert into this is the methanamine. This is the methanamine, and plus this is the NaBr, and plus Na2CO3, and next is your water. So this reaction, this itself tell you the reaction is Hofmann bromide reaction. So answer 4 is our correct answer. First, second, third is wrong answer. Correct increasing order for the wavelength of absorption in the visible region for the complexion cobalt 3 plus is. So we can see there are 3 ligands present in these reactions. And if you see the spectrochemical series, what is the order of the ligand? So order of the ligand is actually En is again bigger, then next is ammonia, and this next is water. So this ligand is very strong in the spectrochemical series. This one is strong. So what will happen? So wavelength will be absorbed according to this ligand will be, this will be highest. So highest wavelength of light will be which is CO H2O 6. This will be your lowest ligands, then followed by CO will be NH3 and whole 6, and highest will be En. So CO En whole thrice, this whole thrice positive. This is highest one ligands, and wavelength absorb will be reverse of this one. So we will see which is opposite of this one. COEN whole thrice will be your first absorption. So again you can see clearly CO is En is coming here, and NH3 here, and H2H this side. So this means that this answer is correct. Someone marked correct answer also. This correct answer. So all the 1 to 4 is wrong answer. Which is the incorrect statements? So NaCl is insulator, silicon is semiconductor, silver is conductor, quartz is piezoelectric capacitor. So this is our correct statement. We can say Frankel defect is favored in which the ionic compound in which the size of the cations and anions are almost equal. So we know in very well in Frankel defect the anion size and cation size not equal, it is actually unequal. So this is wrong statement. Okay, so this is your unequal, this is not equal state, this will be unequal. This is wrong statement. Next is FeO09 has a non-stoichiometric metal deficiency rate. Again we can say this is not the correct statement, this is also incorrect statement. So this is actually FeO09.8. we can write this compound is non-stoichiometric compound, actually it is 0.93 to 0.95, which oxygen is 1 value is given. So this is the only correct statement, this one. So this is also incorrect statement. Density decreases in case of crystal with a Schottky defect. This is wrong because here density is constant. No, this is not called density decreases because due to Schottky defects, what happens? Some of the ions is removed from the crystal, so density automatically decreases. So this is the correct statement. So only 2 options like 2 and 3. These 2 are incorrect statements. So the student will get bonus in these questions because the 2 statement is given incorrect, while 1 and 4 is the correct answer. So this is our question. Equilibrium constant of the following is given here: K1, K2 and K3, and which are the correct answers. So let us check answer. So this is the nitrogen plus hydrogen is giving ammonia. K1 is this one value. Similarly for K2 is this much value, and K3 this much value. So this is the second equation, and multiply 3 into third minus 2. So you will get finally these questions. Okay, so finally this means you will get K is equal to K2 into K3 to the power cube by K1. So here we have this answer is our correct answer. Extraction of gold and silver involves leaching with Cn minus n, and silver is later recovered by what? So this is the reaction of MacArthur Forrest Sinus process. So what is the reaction? Let us see. So this is the reaction of MacArthur Forrest Sinus process, in which silver is reacting with the sodium cyanide. Sodium cyanide is the leaching reagent, and it will leach, it will form a soluble complex, and again this complex is replaced by the zinc, and you will get this product. So zinc is acting as a reducing agent because it's more reactive than silver or gold, so it will displace. So in this answer, what is the answer? Silver is recovered by which zone? Refining, no. Liquefaction, no. Distillation, no. Only answer is this one. So this is our correct answer. The most suitable method for separation of 1:1 mixture of ortho and para nitrophenol. So how do you separate this ortho para nitrophenol? And this ortho and para nitrophenol is separated by the hydrogen bonding, because in case of para nitrophenol we have intermolecular hydrogen bonding. In case of ortho nitrophenol we have intramolecular hydrogen bonding. So ortho will give you intramolecular, or para will give you intermolecular. So best answer will be our steam distillation, because this is only possible. And ortho we have 1:1 in case of by intramolecular hydrogen bonding, and para will not give. So our method will be discrete crystallization, sublimation, chromatum. These are wrong answer. It is because of inability of NH2 electrons of the valence shell to participate in bonding that. So we can see these SN2 plus and lead both are belong to group 14, and in group 14 what will happen? In group 14, if you go down the group, so down the group this NH2 is your more prominent. So this is inert pair effect is more prominent. In this case Pb2 plus is more stronger than SN2 plus. This is more stronger because here NH2 is acting as inert pair effect, here it's not acting. So in this case you can say this is more stable and this is your less stable, right? Okay, so definitely, so SN4 plus is more stable. SN4 plus is more stable, and here you can say PV4 plus is less stable. Okay, so less stable. So now SN4 will, it is acting as a what? This will acting as your oxidizing agent, but SN2 plus will acting as your reducing agent. Okay, and this PV2 plus, this will acting as a your oxidizing agent. Okay, so PV2 plus will be easily your, you can say this is a PV2 will be easy your reduced with PV4 plus, and why SN will be SN4 will be easily oxidized to SN2 plus. Okay, so SN2 plus will act as a reducing agent, and PV2 plus PV4 plus will acting as a oxidizing agent. So our answer is your 3 correct. This is our correct answer.